Hello and welcome to Pythian's Expert Insights, a series dedicated to providing expert knowledge on the bleeding edge of technology. Today we are joined by one of Pythian's team managers in the consulting group and Oracle ace, Michael Abbey. And today we'll be discussing how to manage RI before it manages you.
Hello and welcome to this presentation called Manage Referential Integrity Before It Manages You. Referential integrity is something that has existed in the relational database environment for decades. In the context of Oracle, referential integrity has existed in the database at runtime since version 7, which came out in 1992. We have availed ourselves of the luxury of defining referential integrity as we created tables starting in version 6, but the code was not enforced at runtime until version 7. This is a little bit about the company that's bringing you this webinar, this presentation. I've spent 11 or 12 of my past 16 or 17 years working for Pythian. This is what we're going to talk about, and the interesting thing about referential integrity is it's the sort of thing that a lot of us take for granted and then find out some morning at 2:15 a.m. when all we could possibly want to do is get some sleep, and we're on call and we get paged on an issue that is related to the enforcement or the violation of referential integrity constraints, and we have to do our homework on the fly and try and figure out where the information is stored in the data dictionary. We are also going to discuss during the presentation the concept of naming conventions. Naming conventions are a very interesting puppy. They're very easy to create and they're somewhat more difficult to follow. It's all about relationships. If you live in the United States or Canada, let's use Canada because I'm a little more familiar with it. If you are going to enter somebody's address, you are forced to choose a province, very similar to the way you'd be forced to use a state, or not only use a state or a province, but one that is a valid state or province, defining the relationship between addresses and state or province codes. There are a number of ways to implement referential integrity. The fact that it is enforced by Oracle at runtime, if defined in the data dictionary, offers consistency. In other words, if your referential integrity is defined at the database level using PL/SQL or SQL+, then it will be enforced exactly the same, regardless of what application interacts with the database. The programmatic approach, which is the way a lot of people used to do it, and periodically people still do, is kludgy, because if you have referential integrity defined at the programmatic layer, you would have to make sure that it is consistent amongst applications and between applications. And we all know, being in IT, the length of time some of us have been, that the secret is to have the code running from a central location and therefore only needing to be maintained once and only once. There's a number of different ways that one can define referential integrity. A lot of us use it unbeknownst to us, use it at the create table. For example, a not null column receives a not null referential integrity constraint in the data dictionary, or it can be added using the alter table add constraint approach. The primary key constraint is the one most of us are familiar with the understanding that it is commonly laid on one column, but there's nothing keeping anyone from laying a primary key constraint on a set of columns rather than a single column. The foreign key constraint, of course, is pointing into the primary key constraint on what we refer to as the parent table, which complicates situations where there is a multi-column primary key. If you have a table with a primary key constraint laid on a combination of columns A and B, the foreign key constraints pointing into that table must reference both columns. The primary key constraint, as the slide says, establishes uniqueness, and I've seen it many times, and what this next activity does is it creates confusion. For example, somebody will lay an index on top of a table, not make the index unique, and then lay a primary key constraint on top of that non-unique index. the fact that Oracle supports the laying of a primary key constraint which will enforce uniqueness on top of a non-unique index is somewhat puzzling. Many times when one is confronted with the need to have multi-column primary key, one uses surrogate keys with values derived from a sequence when the rows are initially inserted into the table. We've known about not null constraints for a long time. We've known about check constraints for a long time. The check constraint, of course, does intra-column dependency enforcement, and if one wants to reference columns in another table, data values resident in that other table, one must use triggers. Of course, the final frontier in information technology, regardless of what corner you're in, is human error. There's a lot of stuff that referential integrity does for us to protect us against ourselves, and of course the integrity of the data is something that contributes to the making of smart business decisions. And then we're into naming conventions. If you define a table and have a not null column, Oracle would create a not null constraint in the data dictionary and give it a cryptic name, something like sys_C00526. Constraints are self-defining when, in my opinion, they're properly created. There's nothing like trying to figure out what constraint violation has happened when you're alerted that sys_C00524 integrity constraint has been violated, as opposed to a much more fluid and industrial strength approach. Let's say that that constraint is on top of the master key table. The master key table's primary key constraint, in my opinion, if it were called master_key_pk, that information is readily available to you. My suggestion is that you'd adopt a standard approach for defining your constraints and use it in either the create or the alter approach to laying primary key constraints onto your tables. There's an example. For example, in this sample, the manu ID, there's a foreign key constraint pointing into the manufacturer table. The understanding would be that the manu ID that you're putting in the product table would have to have a row in the manufacturer table with that value before the row can be created. Of course, the foundation of primary key constraints. There's another one with the primary key again. We're looking at the manufacturer table. Besides the fact that these slides are backwards, we would have to create the manufacturer table before we created the child table, so that the rows in the child table could reference the manu ID in the parent table. The exempted column 19 has a not null constraint laid on top of it automatically as the table is created. So we're starting to briefly look here at the impact on the data dictionary. Your best friend will be user constraints, and your second best friend will be a table that is intimately related to user constraints, which is called user cons columns. Many moons ago, the user cons column table did not have the table name in it. I believe that changed in 10 or 11G, and now it reduces the amount of joining that one must do to get the table name into user cons columns. There's your cryptic constraint name with the type of P, surprise for primary, C for check, again P for primary, and R stands for referential. I thought the first time I delved into the values of the data dictionary tables that supported referential integrity, I was surprised to find a constraint type of R for referential rather than a constraint type of F for foreign. So here's the mantra and the marching orders that it's best to follow. As I suggested previously, adopting is great. First of all, creating is great. Adopting a standard approach for a naming convention is even better. And even though we do our technological coercion to get people to follow the naming conventions, it is wise to periodically, through some electronic medium, check to make sure that the naming conventions are being followed. This is something that I originally ran across, very similar to this, but this is a bit of a hybrid to the way that Oracle names its referential integrity, its constraints in the Oracle applications. It seems pretty obvious to me that if my pager goes off at 5 after 4 a.m. on a Saturday morning, that if there's a referential integrity problem and it mentions a constraint that ends in the text _PK, I'm already halfway through the battle. I already know that it's a primary key constraint violation. This is basically a sign. This is an example of 2 alerts that you might get. I don't know about yourself, but I'd feel much happier knowing when I drag myself out of bed. There's 3 things that I know from the alert in the second greenish blue box. I know who owns the table, which I knew before, but I also know that it's a foreign key constraint, and the fact that it says FK1 leads me to believe that there is a very good possibility that this table has multiple foreign key constraints. If you have your first foreign key constraint, what some people will do if they do adopt a naming convention similar to this is they will call the first primary key foreign key constraint FK, and that's the end of that. When they get into multiple foreign key constraints, then they have a situation where the first foreign key constraint is called _FK, and the second foreign key constraint is _FK2. My suggestion here would be to make sure that the foreign key constraints end in a number, even if it is the only foreign key constraint when the first foreign key constraint is actually laid upon the table. This is what I'm much happier with. It opens up a lot of doors. I do know that the create table syntax that people once used primarily, if not exclusively, to create referential integrity. I know at one point in time you could not name your referential integrity, your primary foreign key and whatever constraints in the create table, but I believe that restriction has been relaxed. But this is my preference for laying primary key constraints on top of existing tables and using the alter table construct to put them in place. Here's a little bit more. Notice the first full, but the second statement on this screen in the alter table product. It's saying add constraint product FK, foreign key, references manufacturer, manu ID. The references manufacturer is all that you need in that foreign key definition. What I've done here is I put the manu ID column in, which is understood implicitly to be the primary key column in the manufacturer table, but I do believe if and when you're using the likes of DBMS metadata or export-import to drag constraint definition statements out of the data dictionary, in this case more is less. If it simply said references manufacturer, the puzzle is not complete. But when I say references manufacturer manu ID, I have now informed the reader that the primary key constraint column in the manufacturer table is indeed called manu ID. There's a little bit more. I was talking about intra-table checks. We're checking to make sure that the gender is either masculine or feminine. And what I've always enjoyed amongst everything else about information technology, especially in Canada, is MF, masculine, feminine. Of course, works in French as well for masculin, féminin. Here's again a second example of some inline intra-table check constraints. This is basically what we've set up. We've had a little bit of a look so far at the impact on the data dictionary. There's a little bit more. My only other advice is to consider using a 2-digit number for the foreign key constraints and the check constraints, such that if you ever try and bring the information out of the data dictionary and end up sorting by constraint name, we both know that the number, the sorting of those constraints is going to be messed up a little bit by the fact that sometimes you might have foreign key constraints with 2-digit numbers at the end rather than 1-digit numbers. So here's a little bit of the impact on the data dictionary. Nothing to be surprised about. We're looking for check constraints, and we're giving it a table list, and I don't recall exactly what check constraint we set up on what table, but there's the list of our check constraints. There's the list of our 3 primary key constraints, and there's a look at our foreign key constraints. And those 2 tables, user constraints and user columns, are the only knowledge that you need to have embedded in your psyche to do two things. One of them, of course, is to intervene on alerts that come in reporting difficulties with the enforcement of referential integrity. That's the big one. And of course, the second one is those are the only two tables you need to know anything about to hopefully keep your head on the pillow at night. Here we're looking at something a little bit more involved. There's a little bit more information in there, getting the check, the value of the check column out for edification. I think it's possible that the column in the user constraints table might indeed be blob or long or clob, whatever Oracle's using in 12c. I believe it's clob, and you might have some issues with some of the very long. Actually, I guess it's the search condition column, which, if my memory serves me well, in versions 11 and 12 has been a clob. A little bit more about the impact on the data dictionary. We're still primarily looking at user constraints. What we're doing here is we're looking a little bit deeper into the data dictionary. And I believe I wrote this at the time where the table name was not in the user constraints column, data dictionary, hence the subquery, which looks for information in user cons column where the constraint name belongs to either the product or the legislation table. So this is a summary of the impact on the data dictionary. The fact that it's a constraint type of R for foreign key is fundamental to this exercise, and the relationship between the user constraints and the table that is being the table that it points to that is constraining the values in the child table. The secret is using the R constraint name from the user constraints data dictionary view. This talks a little bit more about some initially cryptic columns. The R constraint name and the R constraint owner, the R owner, I believe, live in the user constraints table. And as it says at the bottom, the search condition ends up displaying the constraining information. It's all fine and dandy to create foreign key constraints, primary key constraints, and whatever type of constraints. And the wise DBA practitioner deliberately goes out of his or her way to make sure that the painstaking creation process and definition of these constraints can be pulled out of the data dictionary. I think this presentation I initially gave before DBMS metadata grew up. It's the most common mess that we get ourselves into, and I probably haven't done it for a couple of years, but I will admit that I haven't done a lot of tech work for the past 3 years, but I'm pretty sure if I look past the 3-year barrier, I would find myself in a situation, as bullet point 2 suggests, that it's all too common through human error to drop the foreign key constraints before we preserve their definitions. And as I'm suggesting at the bottom, every time you do anything to extract information out of the data dictionary, it's a learning process. That's me in a previous life. Of course, timing is of the essence. The time to draw the foreign key constraints is after you've saved their constraint definitions. This is a way to save them using SQL+. I believe when I first put this presentation together, I was using the rule hint because it was in version 10 or 11. The rule hint, to the best of my knowledge, no longer exists in version 12, and you might suffer from the flashing cursor from you know where if you try and run a statement such as this against a version 12 database, but this will grab the foreign key, the primary key constraint, and the columns resident in each one from SQL+. Of course, traditional export-import is something that many of us have used to get this information back out of the data dictionary, with the understanding that in some Linux, I do remember I did not have to do a strings on the export file piped into grep. I was just simply able to do a strings against the export file. And if one does this with data pump, it's very similar. It basically, you bring the information out with a what is the type? I don't remember the type. I don't remember the parameter. I think it's content equals metadata only, and when you bring it back in, you say SQL file equals and provide it the name of a file, which you will find all of the SQL code deposited in during the data pump import. This is what you'll see in export. You'll see something very similar in data pump, but the similarity probably ends the first time you look at it, and they are significantly different. So this is basically preserving the constraint definitions first of all using traditional export and then using traditional import to get the information. That's how I could lay the information on top of some existing tables after I perhaps for whatever maintenance reason happened to drop all of the referential integrity or have a need to do such in the midst of doing some maintenance on the repository. When you bring the data back in, of course, the key word on the import, besides rows equals n, is ignore equals y. I have noticed that even though I do say ignore equals y, and even if I know and Oracle knows during the import process that there are no primary key constraints on the table, it will probably throw an ORA 2264. I haven't tried this probably since early version 11. I'm not sure whether it still happens, but if you're looking for a clean import log, it is very possible that you might indeed have a clean import, but the process has thrown a number of 2264s. It's wise before you drop referential integrity, before you drop constraints, to issue a query against the data dictionary for different schemas to figure out how many foreign primary and check constraints they have. Then you end up going through the process of dropping those constraints, and when you put them back, it's always wise. For example, as we know, even though the number 6367 is huge, if there's 6,367 check constraints, after you drop the constraints, do whatever work you have to do and bring them back in, there better be 6367. 6366, or in the case of the primary key constraints, 1203. 1202 is not good enough. As well, 6366 is not good enough. And the U constraint, and I believe this is also the case in version 12c, is for the advanced queuing constraints that Oracle sets up during the advanced queuing setup. What I'm suggesting here, some best practices. Let's call a constraint exactly what it is. The ability to build a non-unique or a unique index, but in this context, a non-unique index on top of if you lay a primary key constraint, as I mentioned before, on top of a non-unique index, you're asking for trouble. It's an accident waiting to happen. In other words, if you look at the uniqueness in the data dictionary, for a non-unique index that has a primary key constraint laid on top of it, it's a poltergeist. You will find that the non-uniqueness is no, but if that were indeed the case, why is it enforcing uniqueness all of a sudden once one lays a primary key constraint on top of it? My suggestion, since physical partitioning arrived, I believe that was in version 8. We do our best in most situations, although sometimes we're confronted with a need to have a global index. We try to have as many indexes as possible local. So within the limitations of the implementation that Oracle has for physical partitioning, there are some, interesting to use this word, but there are some constraints based on the types of code that gets accepted from SQL Plus to be able to lay constraints on, especially primary key constraints, on the top of partition tables. There is a way to name the partitions at creation time, or you can go back and use a combination of table name, and partition position to make sure that the partitions that are in the local index that are enforcing uniqueness through a primary key constraint are readily available from the data dictionary without having to go any further. What we're doing here, we're renaming partitions. Notice we're using the partition position. Not only that, we're padding with zeros so that every partition position in the index partition names is 3 characters long for appropriate sorting needs. So this is what one can do. I think this started around the time of 10.2, where you could actually lay the index on top of the table. That semicolon after using index local should not be there. And of course, what we're doing here is we're naming the partitions as we lay the index on top of the orders partition table. So that's me. I've been around for quite a while. As I mentioned, I've been working with Pythian for quite a bit of time after the past 17 or 18 years. If you do decide to communicate with me on IM using Pythian MS Abbey or Abbey@pythian.com with Google Talk, just remind me that you got a hold of my IM handle by seeing my webinar about referential integrity, and I'd be happy to discuss anything with you. If you ever have the need to get in touch with Pythian, I think it's pretty obvious, pythian.com, but you know exactly where to find us.
Thanks for joining us for another one of Pythian's Expert Insights. Remember to connect with Michael using the information provided here. And if you want to discover more about our expertise in Oracle, visit the URL included at the bottom of this page or email us at info@pythian.com. Thanks for watching.